Hey, Liberty. Can we go over answers for three and then work on four? Yeah, absolutely. That works for me. So, go ahead and get that open. I don't know who else is here. It looks like it's just you, Liberty. So go ahead and get that open. Let me know when it's open and you're ready to go. Good morning, Rachel. Happy May Day to you. All right, so Rachel, you let me know when you're ready too, and then we'll get started. I do like that idea. Happy Friday, guys. Hope you're doing good this morning. What exactly is May Day, by the way? Is it just May 1st, or is there significance to it? I should probably know this, but I don't. Maybe you guys can give me like a history lesson. What a bummer you. True. I'm sure at some point in my life I knew what it was. You're missing your first May Day. Oh gosh, I don't know what I'm missing though. I'm gonna have to Google this. Sounds like it's fun though. Sounds like maybe there's food involved. It's technically an old pagan holiday where there's this big festival. It's all about spring and fertility. Oh, okay. May Day. Public holiday usually celebrated on 1st of May, the first Monday of May, is an ancient festival of spring and current traditional spring holiday in many European cultures. Dances, singing, and cake. Oh, you had me at cake. All right. I can support this whole May Day situation. I don't know. I don't really know how we're gonna celebrate May Day. I'm sure if we were in school, you two would be conning me into doing some sort of celebration, whether it's a food day or something. So I kind of got out of that one. So typically, everyone in the school dresses up, and then our juniors and seniors get elected to court and elected. Oh, okay. It's like more serious than I thought. I thought it was just kind of like a thing. I didn't know that we actually celebrated it. Ah, all right. And there sounds like there's cake, so I would have been all over that. Yeah, we can go over one too. Oh man. Well, maybe I'll internally celebrate May Day today then. Cool. All right. Well, let's actually, if we're gonna do number one as well, let's just start with that. So let's start with number one, and then we'll do number three, and then if you guys want, you can work on four. All right. So get one out and open. One didn't really involve too much work. So hopefully that assignment, I don't know, did we do that? Oh, we were going to do it Wednesday, but Wednesday kind of took up a lot of time. There's a big assembly and everyone looks nice. It also has a star of spring. Oh, see, I'm so uncultured. I didn't know any of that. I like assemblies and looking nice, so that would have worked out pretty well. So today is the start of spring. Is that just like how people like naturally say it's the start of spring, or is this actually? It can't actually be. But I see what you're saying. Anyways, all right. So I'll start with one. 1A, you should have gotten 6.165 cars per hour squared. Again, 6.165 cars per hour squared. 1B, you should have gotten 520 cars. I think the question said to round to the nearest whole car. So your decimal was 520.07, and you can round that to 520. Rachel said, we're the only school that celebrates it, though, so don't worry. No, it isn't naturally. It's just some symbolism. Oh, okay. I was gonna say, like, I was thinking to myself, like, is this like a normal thing? I don't remember in high school ever celebrating May Day, so I guess that was true. It just okay. I'm following now. Man, I think of May. We're almost if we're treating it as like the start of spring, we're almost in the summer, in my opinion. I think it's like almost the start of summer. When I think of June, that's when summer starts, in my opinion. 1 month of spring sounds kind of sad. I think we need to move May Day to April Day. I think it should be April Day instead of May Day. That's my hot take for today. That's what you guys come for. That's why you join the stream, for the hot takes like that. I'm full of them. Being a new teacher at Vermilion, my first piece of agenda is I'm going to try to change May Day to April Day. Anyways, back to the problem. Number 1, part C. So number 1, part C was one that involved the most amount of work. And you should have gotten 345.5. And then the question asks you to specify what that integral represents. And the integral represents the number of cars that leave the parking lot from 7 a.m. to 5 p.m. or from t equals 2 to t equals 12. However you chose to express that. Okay, and then 1D, you should have gotten 3,530.14, which, when you're rounding that to the nearest dollar, is $3,530. All right, so if you guys want to go over any of those, put it in the chat now. I'm going to move on to 3 and go over those questions, but if you have any questions from 1, we'll come back to it when I'm done talking. Okay, I'm guessing that you guys are good then, or I'm really delayed. Regardless, I'll see in the chat what's going on. All right, so looking at number 3. All right, number 3, part A, difference quotient. You're finding an average rate of change, and you should have gotten negative 1/7. Again, 3A is negative 1/7. 3B, you should have gotten something of this form. Some of you guys may have distributed and FOILed. I don't know exactly what you got to, but at the very least, you should have a step that said y equals negative 3 plus the quantity negative 1 plus 3 pi over 2 times the quantity x minus 3. Again, y equals negative 3 plus the quantity negative 1 plus 3 pi over 2 times the quantity x minus 3. That was 3b. 3c, you should have gotten negative 8. Again, 3c should have gotten negative 8. And 3d, the question was just saying, I think, let me see real quick. I think it just is asking, is there or must there be a value x which fx attains an absolute maximum? So we haven't talked about this one too much. I don't know how much you guys talked about it last year, but I don't know if I've talked about it quite yet this year. I don't think it's come up. But this problem involved extreme value theorem, or EVT, which basically just says if you can prove that a function is continuous from a bound A to B, then f of x has a maximum and a minimum point. It's pretty much simple as that. So essentially what you got to do is you got to prove, is it continuous from A to B? And the way to do that is to check, is it continuous at x equals 0? Because at x equals 0, that's when the functions change, when the piecewise changes from the first function to the second. So we want to check, is it continuous there? Because if it's not, then they're going to be, there'll be a break in the graph, and we can't use EVT. But we prove it's continuous by using the definition of continuity. After you do that, you should get 3 equals 3, which equals 3. And since the limits from the left and the right is equal to f of 0, based off all that information, you can use EVT, which says that yes, there is a max on that closed interval. All right, so that was 1 and 3. So I guess we might as well, if you guys have any questions, 1 to 3, let's just do that now while you have me to do the writing and everything. And then once I'm through those, we can go to number 4, and you guys can start working on that. 3C, yep, no problem, Rachel. Liberty setting gets either. I got negative A as a part of my answer, but not the final answer. Okay. Let me double check. Because you might, maybe I stopped in the middle of it or something. I can check for you. Sounds like something I would do. Okay, yeah, you guys are correct. I don't know why I stopped in the middle of that problem. But let's talk about the general outline. So let me ask you, because if you guys both got -8, then you should have found basically, okay, let's just start with this. So this was 3C. You're finding the average value, which we have a formula for. And that formula is 1 over b minus a, which in this case is your upper bound minus your lower bound. So 4 minus -3 times the integral from -3 to 4 of f of x dx. Okay, so that's what you should have gotten to start. Like, that's just the general outline of this problem. Now, what we need to work on is getting this integral. And we can't just take it straight up because it's 2 different functions, right? So in order to account for that, and it sounds like you guys had a good grasp on this, we want to take this 1 over 4 minus -3, which I should have just changed to 1 over 7, but I didn't, times 2 different integrals. So we're going to split this up into -3 to 0 of f of x plus 0 to 4 of f of x. Because that second part that I wrote there is going to be equal to the integral from -3 to 4. Why I split it up here is because that's when the piecewise change functions, right? And so basically what you're going to do is you're going to find these separately. So you're going to get 1 over 7th, and then multiplied by this integral from -3 to 0 ends up giving you 9 pi over 4. And you can just use your calculator. I think I specified in the calendar to use your calculator for this portion because there's no point in doing anything else. So you end up getting 9 pi over 4, and then 0 to 4 you end up getting is -8. So -8, and then that's where you get 1/7 times 9 pi over 4 minus 8. So that should have been your actual answer. I don't know why I circled -8 as mine. So how does that look for you guys? I know I kind of flew through that, but does that look like the answer you got? Okay, cool. I apologize. That's good. And then D, did you guys get D or follow with what I was saying? Because like I said, I'm sure you haven't seen extreme value theorem in quite a bit of time. So that was good. Okay, cool. Yeah, so if you guys want then and you didn't have any questions from number 1 of this FRQ, if you guys are good on 1 and 3, then go ahead. Now's a good time to start on 4 and should be able to get that done, and then we can review it and you guys will be good for the week. Just so you guys know, I posted that study guide or that AP review thing. I posted that to Google Classroom. So if you guys want to go over that in more detail and stuff, you can feel free. I also okay, Larry, I did that, but I didn't name EBT. Yeah, so I can check real quick. I'm not positive if that was mandatory if you lose points if you didn't name it. Yeah, actually, you do need to name it. So you would have gotten 1 out of 2 points if you didn't name EBT. That's your justification. So yeah, that's good though. At least you got the concept. Just try to to match up the concept with the name of the idea. What I was saying though was I also posted to Google Classroom like this. I forget. I think it's called like the Calculus like Bible or something. And it's just a way. It's like a. I hate to say like cheat sheet, but it's like a cheat sheet for calculus. So if you guys didn't see that post, what it is it's basically just a bunch of formulas and concepts and definitions from calculus. And there was 2 of them. One of them was for the AB portion of calculus. One of them was for the BC. Remembering though, when you guys, if you use it, you don't need to know all the vector stuff and the parametrics and polar coordinate, all that. Like you're okay with that. You don't need that for the test. But I thought it was going to be useful. I think it will be useful for your test. What I mentioned though is try to familiarize yourself with it. So if you are the person, if you're listening right now and you're like, ooh, that's going to be very useful to me, I'm definitely going to use it. Don't just like have it in your back pocket and then when the test day comes, like then look at it. I would familiarize yourself pretty well with it, even study it, try to like memorize it. I know that it might seem like it defeats the purpose, but the more familiar you are with it, the quicker you'll be able to find the information you're looking for, so you're not wasting time. You got 15 minutes for one of your questions. You don't really have 3 minutes to waste to try to go through and try to find a formula or find a concept or a definition or whatever. So, especially like for example, like series. I think it's really going to be useful for series because it lays out all different tests you can do. So like for example, like the integral test, what is required in order to use the integral test? Alternating series test, what are you trying to look for? Stuff like that. Which if you're having a brain fart on the test and you're trying to fly through and you're like, oh, what do I do? What do I do? I think that'll be really useful because you can look at that cheat sheet and it'll remind you of some of that stuff. So. And like I said before, I have a very strong feeling series are going to be on there. So just make sure you guys really are prepared for the series because that's the one topic on this test that's going to separate BC from AB. So I got to imagine. I mean, I'm not positive, but I have to imagine if the AP test wants to somehow separate the 2 classes, I'm thinking that they gotta include a series somewhere. How they do it, they'll probably be creative with it. It might not be a whole question on series, but I think they'll find a way to weasel in there. Anyways, you guys can go ahead and keep working. Just let me know at any point if you have any questions on 4. Ready whenever, and when you get to part C, can you explain it for me, please? Yeah, no problem. All right. So I'll go over the answers, and then when I get to part C, I'll walk you through, and then you guys can let me know if that sounds good to you. Okay. While I'm doing that, I was looking at some A B stuff, so let me pull yours back up. While I'm doing that, though, I guess I can start talking. So the first question, they give you what g of x equals in terms of f of x. So what you wanted to do is get g of 0. So the equation they gave you for g of x, you're just plugging in 0 everywhere you see an x. So your integral ends up being negative 4 to 0 of f of t. That's your answer, and you solve that and you get 3 halves. So g of 0 equals 3 halves. G of 4, same idea, except now you're finding the integral from negative 4 to 4 of f of t. In order to find that, you want to kind of split it up into sections. So, for example, we know one of the sections, I'm trying to pull up the question, I can't remember which one, but one of the sections had an area of 3 halves. That was the triangle one, so we actually had to find that. So, 1/2 base times height. Oh, actually, no, sorry, that was given to us. So the integral from negative 4 to 0 we knew was 3 halves. So we can rewrite negative 4 to 4 as 3 halves. Plus, from 0 to 1, the area was 5, so plus 5, plus the integral from 1 to 4. Putting all that all together, when you actually evaluate the integral from 1 to 4, you end up getting 11 as your final answer. So g of 4 should have been 11. Okay, so for part B, you need to find what g prime of x was. So if g of x was the integral of f of t, then g prime of x is equal to f of x. So that was using the fundamental theorem of calculus to get that one. And the question asked you to find a minimum, I think. Yeah, it asked you to find an absolute minimum. So you need to find when f of x is equal to 0. Essentially, right? When you're finding a minimum or an absolute minimum or maximum, you need to find the critical points and the endpoints. Well, we know the endpoints are negative 4 and 4. We need to find the critical points. To do that, you set g prime of x equal to 0, which is the same thing as setting f of x equal to 0. And you find a bunch of different values. You find x equals negative 4, negative 1, 0, 1, and 4. So those are all the different points you have to check using to find an absolute minimum, which is called the candidates test. Now, we can ignore some of these. So negative 1, 1, and 4 we can all ignore. because increasing values, which all of those are, will give you maximums. So it's the function is increasing at -1, or right before -1, right before 1, and right before 4. So that means that if it's increasing, those can't be minimums. That would make no sense. So we can eliminate those. So we're just down to x equals -4 and x equals 0. So all you got to do is evaluate both of those. G of -4 ends up being 0. G of 0 we already found was 3/2. So 0 is less than 3/2, which means your absolute minimum occurs at x equals -4. And that value is 0. So your final answer is the absolute minimum is 0. Okay, and part C says find all the intervals which the graph of G is concave down. Concavity is completely dependent on your second derivative. So to find where G is concave down, you need to find the second derivative of G. Well, the second derivative of G is equal to the first derivative of f. So essentially what we're looking for part C was we wanted to find out when is the second derivative less than 0? In other words, when is f prime of x less than 0? When we think of f prime of x, we should be thinking, well, we're given a graph of f of x, so to find f prime of x is we're looking at slopes of tangent lines. So essentially the question boils down to this: where on the graph of f is the slope negative? That's the entire question. To find when G is concave down, it's when is the slope of f negative. And so you look at the graph. I can show you on my screen if you want me to pull it up, but you look at your graph and you get 3 different intervals. Rachel, I'm guessing maybe where the confusion came was just are we supposed to guess? Because it's not clear where some of these intervals start, and the answer is yes. Just give a reasonable guess. So for instance, my answer and the one AP gave was x is between -2 and -1/2, x is between 1/2 and 1, and x is between 5/2 and 4. Those were the way I interpreted the graph. Those were the parts that where the interval started and ended. All right, so any questions on any of that, guys? Go ahead and ask. Yeah, and actually, if this was a grade on an AP test, they actually would have accepted you just describe. So you actually didn't need to say. It says the first point of this problem is earned with all 3 intervals, or verbal expressions rather than the intervals also in the point. So you could have just said like what I basically said. The graph is going to be concave down whenever f prime of x has a negative slope. So actually that alone would have gotten you points for this, interestingly enough. But you might as well give an approximation. It's at least somewhat clear where these start and end. All right, well, that was your work from the week. I think the only other thing that maybe you guys want to look over was, did you guys want to get the answers to 2018 practice exam number 6? I don't remember if I gave that answer to you or not. That was from Monday. Oh, no, I did give that. We definitely went over that. Never mind. You guys should be good with that. I do remember going over that. Because I remember someone said, "Oh, that was way that was way easier than I thought it was going to be." Yeah. Okay. Yeah. So then that means you guys are good for the week. I hope you have fantastic weekends, Rachel and Liberty, and maybe someone else who's listening. That's the third person, but I don't really know how that works. Enjoy May Day. Celebrate a little bit. I don't know. Maybe con your family into making some cake or something. But yeah, have a good weekend, guys. The AP test is getting close. I'm sure you guys might have some coming up. I don't know where all the other AP tests are, but I got to imagine all of them are starting to kind of creep up. If you guys ever need anything, any questions for me, please don't hesitate to ask. Enjoy the weekend. We'll be back on Monday with some more FRQs. So remember this assignment for 2019 we're going to continue with next week. So we'll do the other questions next week. So don't need to submit it this week. So just save it for next week. Yep, you too, Rachel. Really appreciate it. Happy May Day. You too, Liberty. Morning, guys. Hey, we're Peyton and Andrew. Good morning, good morning. Happy Friday. Happy May Day, apparently. Happy Friday, Alexis. Happy Friday, Jasmine. Yeah, I learned about, this morning, BC taught me about May Day, which I didn't realize was a thing at all. But apparently, Vermilion, it's a big thing. It's not just a normal. I thought it was just like, oh, it's a fun little day. I guess at Vermilion, we take it pretty seriously. So that's interesting to know. So happy May Day. I'm sure this is a little upsetting for you guys because we're not in school. Doing an assembly, apparently, and other things. I'm sure you guys would have convinced me to have a food day or something. Oh, see, Peyton, you and Alexis are on court. Yeah, so this is actually, I had no clue. I thought this was just like, I thought they were just kind of joking around, just like a casual day, but I guess it's pretty important. So I apologize for you guys, those of you guys participating in it, but yeah, it would have been a fun day today. That's okay. In our hearts, we're going to celebrate May Day. Maybe eat some cake. I just Googled it really quick because I really didn't have any clue of what it was. I guess it's a European tradition, but they said cake. The Wikipedia article said cake. It said cake was involved. I kind of got stuck on the cake part. So that's kind of the way I look at it. Is it's a celebration of the start of spring and cake. That was the moral of the story for me. So you guys can still do that. You can still celebrate that. But I also said, for it to be the start of our I don't know the word I'm looking for, but it's not the actual physical start of spring, but the way we interpret it as the start of spring. I don't really agree with that. I kind of look at it as like, in my opinion, June is the start of summer. So you telling me we're going to have 1 month of spring? No way. So I'm proposing in my first year as a Vermilion teacher, all the power I have here now, I'm proposing that we change it to, instead of May Day, April Day. I know. It doesn't have the same ring to it. I get that. But hear me out. The concept is much clearer and makes much more sense. I like to think of winter ending right around March, the end of March. So that means April 1st would be a good day to start spring. And that's a whole extra month we would get to be happy with springtime. I'm not complicating anything, Peyton. I'm throwing this out there. It's a perfectly reasonable idea. So we just move all the festivities up a month. That's what I think would be a very benefit. Now this year wouldn't have worked because we had spring break. So like it's a workshop. We'll adjust, based off of wherever spring break is, and we'll throw a April Day in there instead of May Day. I know there's thousands of years of traditions of May Day. You guys don't have to give me the spiel, but I'm just saying, like, if you really think about it, it makes more sense to do it in April. Telling me I'm gonna have 1 month of spring? Are you crazy? Who do these Europeans think they are? Maybe you guys can convince your parents or someone to make you a cake for May Day. Payne said, all I know is that we dress up. Yeah, see, now that also is not very appealing to me. I'm not much of a dress up kind of guy. Only if I really have to, I'll dress up. So, like, if I would have to be at school and dressed up, I wouldn't have been as happy. But it would have been, I would have been happy for all of you guys. You guys would have enjoyed your day and everything. But, like, currently I'm just sitting in a t-shirt and sweatpants, and it's pretty awesome. I'm kind of a big fan of it. If I could teach in sweatpants and a t-shirt, I probably would. Currently, I'm just talking to kind of take up a little bit of time, to be honest. Maybe some more people are going to funnel in. It looks like I got 7 attentive listeners, which, by the way, those of you who are in here, that's a part because I didn't have 7 people type in the chat. You're slackers and you didn't read the chat. So shame on you. But that's a good reminder. If you are here and you haven't said anything yet, go ahead in the chats. Don't be so shy. I'm going to call you out, sure, but that's what I do. That's how Mr. Harris rolls. No need to be shy. Give it a couple minutes. So, guys, while we're waiting for other people to hop in, go ahead and get your 2017 practice FRQ out. Get your workout. Get the page open to the assignment. That'll be what we're doing today. And actually, you guys can start with number 1 because I'm going to review. I'm going to give you the answers to 1, 2, and 3. That's what we'll start with. So I won't go over them. I'm just going to give the answers. And then once I'm done with all that, you guys can then be like, okay, Mr. Harris, I want to do 1B, 2C, and 3F, whatever. There is no F. I don't know why I said that, but after all that, then we'll review that stuff that you need to go over, and then at the end of class, I'm thinking is when we'll do question 4. And then question 6 will be for homework. So all 2017 review should be done by next Monday. Moral of the story. We're skipping 5 because 5 is part of the chapter we did not look at. 5 had to do with applications of integrals, which we didn't cover. So you guys are in the clear for that one. Okay, I'll give it about 1 more minute again. Open up. Oh, 2 more people popped in. Very good. So guys, open up your 2017 FRQ practice exam. And we'll look at number 1. That's where we'll start. Get your workout. All right. So I'm gonna go ahead and get started. Again, number 1 for 2017 practice FRQ. I'm gonna go through the answers 1 through 3. So I'll try to go at a reasonable pace. Just follow with me as I go. Once we're done with all that, you guys can type in what you want to go over. So you can do that. What I would do is in the chat, like just as I go through the answers, just put in your chat. Don't submit the chat. Don't enter the chat. Just put it in the chat like 1A, comma, 1B, comma, 2C, comma, 3A, comma. And like just do that like a running total as I go through the answers of stuff you want to review. And then once I'm done talking, you guys can all press enter and I can see all the different questions you have. All right, so 1A, we have this particle moving along an x-axis, and we gotta get some information on it. So the first question was acceleration. You're taking v prime of t to find acceleration. You could do a really big long answer. Well, actually, no, you can't, because this one asks you, part A asks you to find the acceleration specifically at t equals 5.1. So you take the derivative, plug in 5.1 for t, and you end up getting approximately 6.492. Again, 1A, your answer is 6.492. 1B, you want to find where the speed of the particle is 1. Remember, speed is the absolute value of velocity. So you're taking the absolute value of velocity, which means you're taking, you're just taking the absolute value of that function. And so what you can do is you can plug it in your calculator, and you're essentially looking for values of t where v of t is equal to plus or minus 1. So in order for the absolute value of v of t to equal 1, v of t can either be 1 or it can be negative 1. So you graph that in your calculator, you find those spots, and you end up finding t equals 0.772 and t equals 1.401. Again, 0.772 and 1.401. Okay, part C says to find the position of the particle at t equals 4. Is the particle moving toward or away from the origin? So if we're finding a position of a particle, and we're given velocity, to get to position, we need to take an integral. We choose the integral from 0 to 4. The reason being is because we know the position at t equals 0. It tells us the initial position is at 7. So we have to use that somehow. So we're going to set up the integral from 0 to 4 of v of t. Using the fundamental theorem of calculus, that's going to be equal to x of 4 minus x of 0, which gives us the position again. So I used x as my position. You guys probably, that's preferred. If you really wanted to, you could have used maybe another variable, but probably x was what you want to stick with. Anyways, you set up that equation to solve for x of 4, and you get 6.712. X of 4 equals 6.712. Because that it gives me the position at t equals 4, that means it's positive. The velocity at t equals 4 is also positive. So it starts positive and it's moving in a positive direction. So you take those two pieces together, combine them. It means that if the particle is right of the origin and it moves right, it means it's not going to move towards the origin. It's moving away. So your final answer there for it's going to be moving away from the origin. All right, and then 1D, it wants to ask, does the particle return to its initial position? So what we have to do is we have to graph v of t. So you have to look at the graph of v of t and look where it's positive and negative. So at 0, from 0 to 1, it's going to be positive. V of t is positive from 0 to 1, meaning it's moving to the right. So we start at 7, that's the initial position. As time increases up to 1, it's going to move to the right. So it could be at 8, 9, 10, 11, I don't know. It could be any of those. At t equals 1, it starts moving left. Velocity becomes negative, which means it starts moving left. So it's at like 9, 10, whatever it may be, and it's going to move to the left. And what we want to find is, during that point, from 1 to 4, anywhere in between there, while the particle is moving left, does it get back to 7? So to do that, we have to find what is the position at 1 and what's the position at 4. And you'll find the position at 1 ends up being 9.4. The position at 4 we already found from the problem before. It was 6.712. So if it starts at 9.4, it's moving left, and it gets to 6.712, and it's a continuous function, by intermediate value theorem, it has to cross 7. All right, that's the basis of that question. If the particle starts at 9.4, ends at 6.7, and it's continuous, it has to hit everything in between. So 7 is included in that. So it does return to its initial position at some point. All right. Number 2. So number 2, they give you this graph. It has two different lines. One is A of t, one is B of t. All right, so your first part, it says how much water will be in the tank at t equals 4.5. So what we want to find is inside the tank is represented as A of t. So water flows into the tank based off of A of t. And the question for part A only was worried about tank A. So we're completely ignoring the function B of t. Doesn't matter to this question, just ignore it. So to find if the flow rate of water is given by A of t, to find the actual amount of water, you need to take the integral from 0 to 4.5 of A of t. That's all this question asks. You can use a calculator, so you just plug it into your calculator, and you end up getting 66.532 liters. So how much water will be in the tank? 66.532 liters. Part B says, what is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? Well, we know that A of k equals 20.5 because it intersects at t equals k. So in the actual question, it tells us that they intersect at k. A and t and B of t intersect at k. So that means that we know B of t in the question, so part B, it actually says B of t has a constant rate of 20.5 liters. That's the water flowing in. So that means A of k has to be equal to 20.5. So basically what we're doing is we start by solving for k. So you guys solve for k and you get k equals 0.892. And then the actual question wants us to find the integral from a to b of b of t minus a of t. So if we're finding the difference between the amounts in the water tanks, well, the difference is then going to be whatever's in a of t, which is the integral from a to b of a of t, and then whatever's in b of t, so the integral from a to b of t. End up solving that, and you get 10.599 liters. This question's a little bit hard for me to talk about. It's a little bit easier to show. So if you're listening to me right now and like none of these numbers you have on your paper, you should probably type that as a question you want to go over. 2C. 2C again, like I'm not even gonna try to talk about all the different steps in this. There's a couple different things you gotta look at. What you end up getting though is 48.314 liters. So essentially what you should have done was you should have found the integral from 0 to k of b of t, and then the integral from k to 2.416 of b of t. And you do that, and once you do that, you get their final answer of 48.314 liters. Okay, and the last part is D. D, what you're doing is you need to find the difference between WT and AFT. And you want to know if that's increasing or decreasing. So if we want to know if something's increasing or decreasing, we always take a derivative. So you need to take the derivative of WT and AFT, and then evaluate both of those at t equals 3.5. So your final equation ends up being W prime of 3.5 minus A prime of 3.5, which is equal to negative 1.4. Negative 1.4 is less than 0, which means that the difference is decreasing at time t equals 3.5. So your final answer for 2D is decreasing rate. All right, moving to number 3. No calculator on this one. They give us a graph of f. Tells us g of x is equal to 1, the integral from 1 to x of f of t. We want to find the average rate of change from g from x equals 5 to x equals negative 5 to x equals 5. So what we're finding then is g of 5 minus g of negative 5 divided by 5 minus negative 5. Average rate of change, right, we take the slope. Well, some of those pieces we don't know. So we actually have to solve for g of 5, and we have to solve for g of negative 5. So g of 5 ends up being 12. G of negative 5 is 7 plus pi. Put that all together into your equation, and you get 12 minus 7 plus pi. So 12 minus the quantity, 7 plus 5, all divided by 10 is your final answer, the average rate of change. Again, 12 minus the quantity, 7 plus pi, all of that divided by 10. 3b wants you to find an instantaneous rate of change of g. Whenever you think instantaneous rate of change, anytime you think of instantaneous rate of change, you should be thinking derivative. So you need to find g prime of 3. Because it wants you to find the instantaneous rate of change at 3. So g prime of 3 is equal to the derivative of the integral 1 to 3 of f of t dt. Using the fundamental theorem of calculus, that's telling you that g prime of 3 is equal to f of 3. And your final answer is 4 then. So 3b, you get 4. 3c, what open intervals, if any, is the graph concave up? Concavity is completely dependent on the second derivative. So if we're looking at the second derivative of g, that's going to be equal to the first derivative of f. So essentially what we're looking for is when is the second derivative of g greater than 0, or when is the first derivative of f greater than 0, also known as f prime of x greater than 0. We can find that pretty easily. All we're looking for is at the graph of f, if f prime is going to be greater than 0, it means it's a positive slope. So where on the graph of f is there a positive slope? That's what this question's asking. And there's a positive slope from negative 5 to negative 2 and from 0 to 3. So your final answer is the interval negative 5 to 2 and 0 to 3. Part D says to find critical points. So to do that, you set g prime of x equal to 0, which means whereas f of x equal to 0, you can find that occurs at x equals negative 2 and x equals 1. Now we have to classify those two critical points as local mins or local maxes or neither. So you need to use a sign chart, and you get from negative 5 to negative 2, f of x is negative. From negative 2 to 1, it's also negative, and from 1 to 5, it's positive. So that means at x equals negative 2, there is no critical point because it doesn't change direction. It stays negative, meaning the derivative of g is still negative the whole time. So that means that there's neither minimum or maximum at x equals negative 2. And at x equals 1, it changes from a negative slope to a positive slope, which we consider a minimum point, a local minimum. All right, that's 1 through 3. So I will let you guys, now is the time, if you've been tallying what questions you have, go ahead and type those in right now, and I will wait, look at all of them, and then we can start reviewing. Okay, 2. Okay, so definitely 2. Looks like it's going to be something you want to go over. Looks like 3 as well. At least the first part of 3 looks like we want to go over. Jasmine, 1C, 1D. 2B, 2C, 3B. Okay. Don't be shy, guys. Please, any questions you have, please give me them. You have about a minute more to let me know. Okay, so I only got 3 responses. I don't know if that just means that everyone else just doesn't want to talk, or if everyone else is kind of good with going over anything. Because maybe either they didn't do the assignment or they're just not really positive about any of it. Regardless, it's okay. I'm just going to kind of take those then, the 3 people who responded. I'm going to go through some of their stuff. So it looks like I'm going to do 1C, 1D. I'm just going to do all of 2 on paper, and then I'll do maybe all of 3 as well. We'll see. See how the timing goes. Okay, so 1C. Question says to find the position of the particle at time t equals 4. Let's strictly focus on that. Position of the particle at t equals 4. Okay, well, we know the velocity of the particle. How do we get position? Well, to get position of a particle for given velocity, remember it goes from position, the derivative of position is velocity, derivative of velocity is acceleration, which means the integral of acceleration is velocity, the integral of velocity is position. So we need to find an integral of velocity. Okay, but the question is, what bounds? That's the key. How do we find the bounds? Well, we know that we have to look for x of 4, the position at 4. So 4 has to be one of our bounds. In this case, it's our upper bound. Okay, now the lower bound. We need the lower bound to be something we know. So hopefully what you're thinking about right now is the fundamental theorem of calculus, which states that the integral from something to something of v of t is going to be equal to the x of the first bound minus x of the second bound. So I need the second value, whatever it is, I need to know what it is. So it needs to be x of something I know. And in this case, I know what x of 0 is. Because the first in the actual beginning of the question, it tells me at time t equals 0, the position is 7. Okay, so this is the equation. That's all we need. We need to solve for the position at 4. So we add x of 0 to both sides. Which means that 7, the position at 0 is 7, plus, you guys would use your calculator for this. So we know what the actual expression for v of t is. You just plug this into your calculator. So I'm just going to keep it like that. And you end up getting 6.712 equals x of 4. So that's the first part of the question. The first part of the question says, what is the position at 4? So x of 4. And we found that is 6.712. Another big piece of information we need to know is v of 4. Remember, we have the function for velocity. We have the function for v. So to find v of 4, you're just plugging in 4 into the original equation. And you get 1.213. So the position is 6.74 or 6.712. The velocity is 1.213, which at the end of the day tells me this. X of 4 is greater than 0. V of 4 is greater than 0. So particle starts right of the origin and is moving right. So away from origin. Now that's like a poorly written one, but you know that pretty much sums it up. Payne, what do you do if you can't plug it into your calculator? So I know you really can, Payne, because I had that calculator and I did have to do it. I know it's not easy and it's not like ideal. So I understand that. You really can, if you practice enough, you can do that in that calculator. It just involves commas and annoying parentheses. But if it's too much, you can use an online calculator. So I'm pretty sure, I'm looking actually right now, I think Desmos will do it. Yeah. So if you look at, I'm sure Payne's not the only one, so let me actually put my screen up. If you guys go to Desmos, you can see if you go to functions, so you pull up your keyboard, you go to functions, and you go to miscellaneous, an integral will pop up right here. So like for this example, you do 0 to 4. You'd plug in all of your parts. So I don't want to spend time doing all that, but you'd plug it all in and it'd give you the answer. So if I were to just do like 2x, I don't know, maybe you have to do dx. Yeah, okay. So make sure you specify what variable. So you're taking it with respect to x. That's the only strange thing, but that's your alternative, Payne. I would highly recommend though, because especially like I know you specifically, you plan on taking BC next year. So if you're going to take BC, we got to get used to using our calculator anyways for it. Okay, so yeah, what you guys get then is if your position's right of the origin, you're moving right of the origin. There's no way it's going to move towards the origin. If you think of a axis, right? If I'm starting here and I'm moving that way, where am I moving? I'm moving away from the origin. Oh, can't even see me. So you start right of it and you're moving right. This is the origin. You're moving away from it. And that's 1C. Let's look at 1D now. 1D says find the position of the part. Oh wait, no, that's 1C. During the time interval, does the particle returns to its initial position? Okay. So, first step. Graph V of t. So in your calculator, you'll throw in V of t. All right, I think it's gonna be worth it, so I'm gonna do it. Oh, nice. I already have it in there. All right. Oh, hey, Ethan. Not evening. So you might be a little off. Maybe your clocks are a little messed up, but good to see you. So guys, when you plug in your actual function, this is what you get. I changed the interval because we're only curious from 0 to 4, so I changed the interval from 0 to 4. And this is the graph of V of t. So what I want you to notice is what is V of t telling you? Well, V of t is telling me velocity. Okay? Velocity is giving me which way the particle is moving. If it's a positive velocity, the particle is moving right. If it's a negative velocity, the particle is moving left. So that means from here to here, the beginning of that interval, it's positive, which means it has to be moving to the right during that time. So I need to figure out, where do we start? Okay, so you're graphing V of t. Start at V of 0 equals 7. That's where we start. So we graph V of t, and we can see we start at V of 0 equals 7. We're moving right from 0 to 1. How do I know that? Because the velocity is positive. So I'm moving right from 0 to 1. I know that I'm going to be right of 7. I need to find what that point is. at 1. I need, right when I stop moving right, I need to find what that point is. Okay, so that tells me that I need to know this. What's my position at x of 1? Okay, to find the position, you take the integral of velocity. Why did I choose from 0 to 1? Because it's the beginning of my interval. This whole statement is classifying when I'm moving to the right. Okay, and I'm going to do the exact same process. So I'm adding x of 0 to both sides. And I'm getting this equation. Again, this part you put in your calculator. So you just throw it in your calculator. We know this is 7. All right, so doing the math on this, you get 9.404, or 3, however you rounded it, is the position at 1. So my particle starts, once it hits 1, it's at 9.404, which makes sense, right? We know it was moving to the right, so it started at 7. We know it was moving to the right, so this number has to be bigger than 7, which it is. So we're in pretty good shape. We also know the fact that 6.712 equals x of 4. Mr. Harris, why do you care about that? Well, again, that's the position when it's moving to the left, it ends at. So look at this. I know I'm moving to the left starting at x equals 1. That's what my graph of v of t is telling me. So I started at 9.7 whatever at 1, at x equals 1. And then I kept moving to the left until eventually I stopped moving to the left and I ended at 6.712. We know x of t is differentiable because we can take a derivative of it, right? The derivative is the velocity. So we know it has to be differentiable, which means it's continuous. So I don't want to write all this out just for the sake of time, but essentially you're just saying is by intermediate value theorem, there is a value, or it does return to position. It returns to starting position or initial position. It being the particle. So we've seen intermediate value theorem a ton with these FRQs, which hopefully is ringing a bell and you guys are understanding that and noticing that. But intermediate value theorem says that if we have a range of values and its continuous function, has to hit everything in between. Has to hit 8, has to hit 8.5, has to hit 7, has to hit 7.2, has to hit 6.9, has to hit everything. All right, that was 1D. Okay, let's look at 2. Now 2 was a little bit of a doozy. This is probably one of the hardest free response questions we've had so far this year, I would say. So I'm gonna look at this. I don't want to go too fast, but I do want to get to 3 as well. So try to bear with me here. If I go too fast, you can always rewatch this stream, and you can slow it down a little bit. So they give us a bunch of information. They give us what AFT is. They give us a function for AFT. They don't give us a function for BFT, but we have at least a graph of it. That's it, okay? So the first question is how much water will be in the tank at time t equals 4.5. All right, so we know that AFT, that's going to be rate of water into tank A. That's the flow rate of water going into tank A. That's what AFT represents. It's important we understand the context of what AFT is. That's what the actual function is. So if that's the rate of change of the water in tank A. To actually find how much water there'll be, you need to take the integral of the rate of change. So hopefully, again, like we know to go from velocity back to position, we take an integral. To go from a rate of change or a derivative back to the original function, we take an integral. So if AFT is the rate of change, to get it so it's no longer rate of change, just of amount, you take the integral. So I know I need the integral from AFT. The actual question wants me to find t equals 4.5. So I need to find 4.5. So I'm going to make that my upper bound, because that's what I'm looking for. So I know that's going to be a of 4.5 minus something, a of something. How do I know that? Because fundamental theorem of calculus. What do I make my lower bound? Well, I'm making it 0 again. And hopefully you guys are seeing this trend. Okay, usually it's going to be 0 because it gives us what the initial condition is. Right, we start, in this case, it's starting, both tanks are empty at t equals 0. By the way, you actually don't even need to do this now that I'm looking at it, because we know what a of t is. So all you really need to do is just find that. So let's actually just scratch that. Don't even need to worry about that. We're making our initial bound, our lower bound 0, because time can't be negative, right? When you're starting timing something, you start at 0. So it wouldn't make any sense to go any less than 0 or any other value than 0. So from 0 to 4.5, now that I look at it, you can just throw that into your calculator, because we know what a of t is. Throw that in, and you get 66.532 liters. You would have gotten the same answer doing it this way, but I figure I might as well make your lives even easier. Okay, that was 2a. That's probably the easier part of the question. Now let's look at 2b. All right, so 2b says during the interval 0 to k, water flows into tank B at a constant rate of 20.5. All right, so what is that saying? That says that B of t equals 20.5 from 0 to k. What is the difference between the amount of water in tank A and the amount of water in tank B at time t equals k? So what we're looking for, the actual part of the question we're looking for is then, if we want to know the amount of water and we're giving two different rates, we need to take the integral of the difference. So it's the integral of a of t minus b of t. And I'm just going to put my bounds as a of b right now because we don't really know what that is yet. Okay, so let's actually find what the bounds are going to be. Well, I know my lower bound. By this point, hopefully, right, it's starting at 0. My lower bound's starting at 0 because it's easy. I know that at 0, it's going to be that both tanks are empty at t equals 0. That's when we're starting filling the tank. So like we might as well make that our lower bound, makes our lives pretty easy. Plus, that's where we start the time. And we want to know at k. That's what we're actually looking for. What's happening from the point 0 to k. Okay, so we're left with this integral. And I'm just going to highlight it like that, and we'll come back to it. But we need some pieces of it first. Now, here's some stuff we know. A of k is equal to 20.5. How do I know that? Well, let me go to the actual problem. Look at this graph. This point, if I had this on a piece of paper, I'd put a point there and I'd label it k. This is t equals k, that point right there. And it says the graphs of a of t and b of t intersect at k. So that's k, they're intersecting. Which means that if b of t equals 20.5 there, what does a of t have to equal? 20.5. So if a of k equals 20.5, then that means 20.5 is equal to 2k minus 5 plus 5e to the 2 sine of k. I'll go to my camera real quick. A of k is equal to 20.5, which means 20.5 is equal to the expression for a of t, but replaced with k. So 20.5 equals 2k minus 5. So where am I getting this from? Again, guys, that's coming from this formula right here, the formula for A of t, except now we're saying A of k, not A of t. All right, for the sake of time, I'm not going to go through and put this in my calculator, but what you guys would want to do is throw 20.5 in your calculator, throw this function in your calculator, find where they intersect, and you end up getting k equals 0.892. So I'm going to take this red part that I highlighted, I'm moving it down. That means my new bound is going to be 0 to 0.892. A of t, wait, hold on. I'm sorry. I might have messed something up here. Amount of water and okay, it's not gonna matter. All right. So going from here, then I'm gonna do A of t minus. I know what B of t is that entire interval. So from 0 to 0.892, I know what B of t is. It tells me B of t is 20.5. It's a constant. It remains 20.5 the whole time. So I don't even need to put a B of t function. I don't need a function. I think that's a really important piece that maybe some people forgot. B of t equals 20.5 the whole time. All right, and then the last part, like I've been saying, put in your calculator. You get 10.599 liters. Now, I think with the way this is written, you're going to get a negative 10.599. If you guys put that in your calculator, remember it's the difference. So it's just telling you that there's a difference of 10.599. So we can just round that up to a positive value. I guess not round it up, but we would just make it a positive value. Okay, moving on to 2C. It's a really long problem. I probably have enough room. All right, so 2C. The question is saying the area of the region bounded by the graphs of y and A of t and y of b of t for k to 2.416 is 14.470. How much water is in tank B at time t equals 4.16? All right, so now we have a new interval. Our new interval is k to 2.416. So if we're finding how much water is in tank B, that means we need to find the integral from k to 2.416 of b of t. Now, the issue with this is we need to somehow create an equation that's going to involve b of t because we don't have the function. So I can't just say this. Like I can't just put b of t and just solve it. All right, that's not going to do me any good. So instead what I can do is I can keep with this idea of a difference. So if it's the area of a region bounded by the graphs of y equals a of t and y equals b of t, and now that I'm looking at it I don't actually think this is going to be on your AP exam. So since I started it, and I'm sure people are curious, I'm going to keep going, but don't freak out if this is something that you're not understanding. Because now that I'm looking at it, I don't think you'll see this on your test. Because I think this is something that you would see in Chapter 8. But I'm going to keep going anyways. So we're finding that the area of the region bounded by the graphs of these two is equal to 14.470. So this is the representation of area bounded between 2 points. So we know area under a curve is just the integral of a function. To find the integral or the area between two curves is you find the integral of the upper curve, which is a of t, minus the integral of the lower curve, which is b of t. Okay, and we can use rules of integrals, and we can rewrite this as the integral from k to 2.416 of A of t minus k to 2.416 of B of t. That in total is going to be equal to 14.470. They told us that in the question. They said that area is equal to 14.470. Which means the actual question of what we're looking for just B of t by itself, which means if I subtract the integral from k to 2.416 of A of t to both sides, I can then divide by a -1, and this will be what I'm actually looking for. This is what I'm actually looking for. The question didn't want to know the difference because it tells us that. It wants to know specifically how much water is in tank B. So this part, I know what k is, by the way. I keep putting k because I don't want to write out the 0.892, but I actually know k is 0.892. So I'll write that off to the side. We found that in part B. And of course I ran out of room, so I got to flip to the back. If you put this expression, if you put this into your calculator, you will find that the total answer ends up being, make sure you're in frame, the total answer ends up being the integral from k to 2.416 of B of t dt is equal to 30.027. And that's great. So if I look back, what I just found is I found how much water is in my tank from here to here. That's what I just found out. On B of t, how much water is in the tank from this point to this point. But I need to find how much water was in the tank from here to here as well. I have to add those together because it didn't just start randomly pouring into the tank right here. It started before that. So I have one more thing I need to find, which is the integral from 0 to k of B of t. And that's equal to 20.5 times k between 0 and k. Let me switch over. So if you're wondering why that's the expression I get, well, because from 0 to k of B of t, well, B of t is 20.5. So essentially, this is just saying, just write this down, this is equal to 0 to k of 20.5. And the integral from 0 to k of 20.5 is 20.5k. So that's where that comes from. Remember, I'm using k, but I know what this value is. So instead of like putting k, you can just plug in 0.89, whatever. And this ends up being equal to 18.287. So I have 18.287. I have 30.027. You add those together, and you get 48.314 liters. This gives me the amount in the tank B from 0 to k. This gives me the amount of tank B from k to 2.416. Total amount is those two combined. It's taking way longer than I thought it was going to be. I apologize. Last question is not too bad. So the last question is not 2D. Just gives us this interval from 2.7 to 4.5. We have a flow rate. So the rate at which the water flows into tank B is modeled by W of t. And they want to know, is the difference of W of t and A of t increasing or decreasing? So to find that, we got to find w prime of 3.5 and a prime of 3.5. To find w prime of 3.5, you're going to use your calculator. So you would take the derivative of w, which we were given w. So you take the derivative of w, evaluated at 3.5, and you get negative 3.786. A prime of 3.5, same idea. You take the derivative of a, which was given in the original question, evaluate that at 3.5, and you get negative 2.643. Take these values, subtract them, and you get negative 1.14298 is less than 0. Just so everyone's know, I'm changing the homework because I'm not going to be able to go over number 4. So for homework, guys, your homework over the weekend is just to do number 4, not number 6. We'll do number 6 in class on Monday. Well, during the stream. Okay, so to continue with what I was saying, though, if you subtract this difference, w prime and a prime, you get negative 1.142. That's the difference between the two, which means that that's negative, so it's less than 0. So the final answer is decreasing. If you get a negative derivative, then you know it's going to be decreasing. Again, that was probably one of the hardest FRQs you'll see. So any questions, anything you guys need me to go back and reiterate, because I went through that pretty quickly? Okay, no one's in the chat. I'm assuming you guys are just like, what the heck is going on? Hopefully not, but again, if that stuff went really quickly and you need to kind of take it slower, please just rewatch this stream and skip to that part, and try to like re-listen to what I was saying, and then hopefully I didn't miss anything important. Hopefully you can follow along. I apologize. I'm just trying to get through some stuff for you. So moving on to number 3, you have this graph of f, right? It tells you g of x equals the integral from 1 to x of f of t. First question says to find the average rate of change of g, also known as AROC. So the average rate of change is going to be g of 5 minus g of negative 5 divided by 5 minus negative 5. That part's easy. That's an average rate of change over an interval. It's just a slope. So you take a slope from negative 5 to 5. The part that's not so easy is the fact that we don't know what g of 5 and g of negative 5 is. So we got to split this up into 2 separate calculations. Well, if I know that g of 5 is when x is 5, and I know g of x is that integral up here, which means g of 5 is the integral from 1 to not x, 1 to 5 of f of t dt. Okay, and this is going to be really annoying because I don't have this on paper or anywhere to actually show you, but I can kind of do it with my mouse here. If I want to find the area under the curve from 1 to 5 of f, this is what I'm looking at. This point right here, this is 1, 5 is right here. That's 5. So I need to find the area from here to here. To do that, I'm going to split this up. I'm going to split it up into a triangle starting right here. So I have this right triangle from 1 to 3. The area of a triangle is going to be 1/2 base times height. So base is 2, height is 1, 2, 3, 4. 2 times 4 is 8. 1/2 times 8 is 4. Now, what's left is I have this rectangle. So I made a triangle here. Now I have a rectangle for the rest of the interval. So the rectangle is from base of 1, 2, or length of 1, 2, height of 1, 2, 3, 4. 2 times 4 is 8, so 8 plus 4. Which means that this integral is equal to 4 plus 8, which is 12. Okay, and we're going to use the same principle for g of negative 5. However, look at my bounds for g of negative 5. It's kind of annoying, right? I'm going from lower bound. That's supposed to be the smaller number, but that's the bigger number. So to adjust for that, I take a negative out front, and I flip the bounds. So my new equation is g negative 5 equals negative 1 times the integral negative 5 to 1 of f of t. Okay, and I go back to my graph. I'm looking from negative 5 to 1, so I'm looking from here up till here. All right, so my first area is going to be this triangle. All right, this triangle has a base of 1, 2, 3, a height of 1, 2, 3, 4. 4 times 3 is 12. 1/2 of 12 is 6. However, it's negative. So I end up getting negative 1 times negative 6 is the area of this triangle. The area of this little semicircle. So from negative 2 to 0, I'm looking at this area here. And it's not a semicircle, actually. It's a quarter circle. I don't know. There's definitely a word. I'm just not thinking about it. But this is actually a quarter of a circle. So to find a quarter of a circle, it's going to be, if the full circle is pi r squared, right, the area of 1/4 of that is 1/4 pi r squared. All right, my radius is 2. So 1/2, or 1/4, 2 squared. 1/4 of 4, or wait, sorry, pi. I forgot about pi. So it's pi r squared. So it's 1/4 of pi r squared, which is 1/4 of 4 pi, which is just pi. Again, it's negative because I'm beneath the x-axis. So this area of this little tiny quarter circle is negative pi. And then the last one is this tiny little triangle from 0 to 1 here. 1/2 of the base is 1/2. 1/2 times 2 is 1. Again, negative because it's below the x-axis. So going to my paper, you can see this area is equal to negative 1 times negative 6 minus pi minus 1. And you can simplify that, distribute the negative 1 and simplify, and you end up getting 7 plus pi. All right, so now I have all the pieces I need. I'm just going to plug them back in. So g of 5 is equal to 12. So I'm going to take this average rate of change. So it's going to be 12 minus g of negative 5 is 7 plus pi. And then 5 minus negative 5 is 10. So that's where I get my average rate of change from. Let me go over 3b. So I'm going to go over 3B really quick because this shouldn't take very long. I want to make sure that you guys don't feel like, I didn't go over everything. I know I didn't in person, but please, if you have a question on anything else from these assignments, email me today and I'll answer them. So don't be hesitant for that. Email me, or if I don't answer them today, I can answer during the weekend, whatever. Just if you still have questions, let me know and I'll get you your help. Okay, the last question though, this one's gonna be pretty quick. So I'm gonna go over this and then algebra will start. This is just 3B. Okay, so for 3B it says find the instantaneous rate of change of g. Okay, well the instantaneous rate of change of g is the same thing as g prime of x. But we want to know with g at x equals 3. So really we're finding g prime of 3. Well, g prime of 3 is equal to the derivative of the integral from 1 to 3 of f of t dt. Because g of x is equal to this, so when I take the derivative of g of x, which is g prime, I take the derivative of that side as well. By the fundamental theorem of calculus, this whole expression on this side is just equal to f of 3. That's by the fundamental theorem of calculus part 1. F of 3, we just look at the graph that was given to us originally. Look at when x equals 3, and you find that y equals 4. So that's how you get 4. All right, guys. So that'll be all for calculus. Ran out of time. If you have any questions on 3C and 3D, like I said, email me individually, and I'll be more than happy to help you out. They're not too complicated. 3C and 3D aren't like crazy amount of work. So you guys can see your calendar changed. So since I didn't get to go over number 4, you guys will just do that for homework this weekend. So you won't be doing number 6. Number 6 will be on Monday. We'll go over as a collective unit. Question 4 is your homework this weekend. So thanks for being patient. Thanks for listening, guys. I hope you have a fantastic weekend. Happy May Day. Find a way to celebrate. AP test is coming up, so hopefully you guys are studying. If any of you are still in here, thank you, Haber. You too. I did post a little study guide for you guys. Not even a study guide. I shouldn't say study guide. It's a cheat sheet kind of. Have a great weekend, Alexis. So in Google Classroom, I did this like a little cheat. It's called like the Calculus Bible, I think it was called. But it gives you all the stuff you've learned. So it gives you definitions. It gives you formulas. It gives you concepts. It covers a ton of calculus in just a few pages. So familiarize yourselves with that. I would definitely take a look at that if I were you guys. Check to see if it makes sense to you. If there's stuff that you want to review, don't just save it for the AP test. Look at it now. That's all I got for you guys. Have a great weekend. Hey Jane, you're not late. This is just a review day, so I'm not teaching anything. If you have a question specifically on an assignment, please feel free to ask. But yeah, no worries. This is kind of just a nice and open hour for you guys to stop in. What have you been doing, Jane? Let me hear. What's your day been like today? Going to get groceries and dropping off things at the post office and going to Dunkin' Donuts. Nice. It is a busy morning. It's good though, Jane. You're getting stuff done in the morning. I respect that. What'd you eat from Dunkin' Donuts? Did you get any maple bacon donuts? I don't know if they have them there, but I know those are your favorite. We had iced coffee and blueberry cake donuts. Double chocolate cake donuts and me. Wow. Jaden, living the life. Sounds awesome. Happy May Day. I guess you can kind of celebrate with your all those snacks you got. It sounds delicious. Can we go over fx equals -2? It is a graphing one. Oh, okay. Yeah. No problem, Jaden. Okay. So here's what we're gonna look at. Let me see, make sure I have my alright. So we want to graph -2 divided by -x minus 5. Okay, so that's what the question's asking. Now, easily, the graphing portion is pretty easy because like all I wanted you to do is put it in Desmos to graph the actual lines. So you'll get a line by graphing, or multiple lines, multiple curves by just putting that in Desmos. So that's step one to graph it. You want to get that established. But what's really important, the thing I really want to focus on in these problems is asymptotes. So we have a horizontal asymptote and vertical asymptotes. Those are our options. We also talked about, very, very briefly, we talked about these slant asymptotes, which we're not going to get into detail on. Vertical asymptote. We find a vertical asymptote when denominator equals 0. So in our case, it's when -x minus 5 equals 0. Which means -x equals 5, which means x equals -5. So when it gives you an option to put your asymptotes into your graph, one of your vertical asymptotes needs to be at x equals -5. Okay, so that's the first part you needed, Jaden. And then the second part is the horizontal asymptote. And we need to look at the degree of the numerator and the degree of denominator. So the degree of the numerator is 0 because there's no x's. It's x to the 0. Degree of the denominator is x to the first, so it's 1. Because 1 is greater than 0, horizontal asymptote occurs at y equals 0. So since the degree of the denominator is greater than the degree of the numerator, we have a horizontal asymptote at y equals 0. Oh, man. And unfortunately, Jaden, I think for this one, I was trying to create this assignment so you didn't have to, it wasn't the case, but I think with this one, you actually might have a slant asymptote. Which stinks. I really was thinking that they wouldn't do that. Yeah, so Jaden, before you submit real quick, I'll show you just because you came to the stream, and I really didn't intend. This is why for this assignment, I'm just going to grade if you do completion. Between me and you, I'm grading on a completion. Yeah, but you can see for this one, I think it's going to be, it looks like there's going to be a slant asymptote, which means that I need to make a division problem. So you would make a division problem and go from there. So in this case, your actual, you actually don't even need to do this. So Jay, just so you know, your slant asymptote is going to be, I'll just put this right down here. at negative x minus 5. Okay, so yeah, Jaden, give me 1 second. Actually, I don't know if you've already submitted it. This one might not actually have um, a slant asymptote. I can't remember now. I'm having a brain lapse. Okay, yeah. Before you submit it, let me ask real quick. I'm gonna check the textbook. Which will take another 10 years. You have any plans this weekend, Jade? I know you can't really go out, but I wasn't sure. Maybe you have you want to play board games with your family or something like that. I don't know. Paint the rooms in your house? Not the most fun thing to do in the world, but painting's actually pretty relaxing. As long as you don't make any mistakes, it's actually a pretty relaxing experience. We did the bathroom in my sister's old room when she moved out. Oh, cool. So, are you painting the whole house, or are you just painting certain things? Also, just so you know, Jaden, there is no, ignore this, there's no slant asymptote. The slant asymptote's when the degree of the numerator is 1 greater than the degree of the denominator. In this case, the degree of the numerator is 1 less than the degree. So ignore the slant asymptote part. Your answer is going to be the graph with the vertical and horizontal asymptotes. We still have to do the kitchen, living room, and the hall. Oh, wow. So yeah, you really are. This is a big project.
I need a haircut, but the woman I got to can't do it right now, so I'm going to look like Jaden. Trust me, I was actually thinking about this more. That's one of the most frustrating things for me right now is I can't get a haircut. It's driving me nuts. I need one so bad, but everyone's gonna be shaggy looking, so don't worry. Um, no, Jay, not really. I'm gonna make some dinner. Tomorrow, I think I'm gonna have a friend come over. We're gonna make some dinner. I think I will just kind of take it easy, get ready for next week. All my stuff for teaching, and just kind of relax. Maybe watch a movie. Saw you on the Vermilion YouTube video. Yeah. What'd you think of that, Jay? Did you like that? I made a couple appearances. You too, Jaden. Appreciate it. Have a great weekend. Yep, I'll see you Monday.